Hey, hi everyone. Um, Let me introduce myself first. My name is Bharat Kumar. I have overall 4 years of experience in Power BI. Today, I will walk you through the most important topic in Power BI, that is data modeling. Data modeling is the foundation in any BA project. Without a proper data model, even the best visuals or reports won't give accurate insights. In this video, I will explain you what are the fact and dimension tables are and why we need them and how the relationship works and what are the schemas and designs we use in Power BI. So let's go to the topic. Um, First topic is a dimension table. So it is a type of a table which contains string data as well as a primary key column in it. So, this is the dimension table. For example, it contains most of the data is a string data type only. The string is nothing but text type. So, and also it has primary key column. Uh, so how can we find out whether it is a fact table or a dimension table? So we have some characteristics for this. So let's go to the characteristics, like it has a fewer rows and more columns, rich in descriptions. So that means it always explains the data only. It always explains about the products, categories, and dates. Like that, it always explains. And each row has unique primary key column. So you could see here, uh, every ID is a different. See, every ID is different, so that we can find out based on the primary unique column. We can find out it's a dimension table. That is one of the characteristics, and it may include hierarchies. For example, it has it might have a year column, quarter column, as well as month column in this table. So in the based on such characteristics also, we can consider it as a dimension table. Let's go to the second topic, that is a fact table. uh, what is the difference between dimension table and fact table means? So dimension table contains what string data, but it has numeric data. You could see here, it all the things are in numeric only. So I can't say it contains only the numeric. Sometimes in real time we have uh, string data also. And the second, as it contains as well as a foreign key also. So foreign key, it is a foreign key here. So it when you consider it as a primary key in this table, there might be another table, it considered as a foreign key. Yes, foreign key. So how can we find out? It is a fact table. So it has some characteristics in it. So what are the characteristics? So very large in row count, but relatively few columns. You know, rows are in a higher number, but columns are in a lower number. Okay, that means it's long and narrow in structure. Foreign key is connected to the dimension tables, yeah, as we discussed. So foreign key, this is a foreign key here, and it is connected to the dimension table primary key. And we can consider another characteristics, data often repeated. You could see here 103 is here, 103 is here. So like that, the data may be repeatedly comes. So, and in short forms we can say fact table contains what happened. We can easily say what happened in the that related data. In dimension table explains about what. See, this explains what are the products here, what are the categories here. So like that it explains. So with that products, what's happening around here in the data set. So it explains this thing. So as for we know what is dimension table and what is fact table. Dimension table contains primary key as well as string data. Fact table contains numeric data and foreign key. So this is the main difference. And uh, dimension table has fewer rows. It has fewer rows and more columns in it, but it is um, row count is high. The column number is less relatively, when it compares with this. And let's move into the next topic. That is, we may got a question like, why do we need fact tables and dimension tables? Can't we store the data in a single table? So good. Technically, yes. Yes, technically, we could store the everything. We could store everything in a single loss table. But fact tables, dimension tables are built for efficiency, flexibility, and clarity. Um, and the reasons are avoid data redundancy. Redundancy is nothing but duplicates. It avoids duplicates. Performance may be improves, and flexibility in analysis, and data consistency. So, so because of these reasons only, fact tables and dimension tables are built for what? Efficiency, flexibility, and clarity. So if the data is segregated in different ways, so we can understand what for a particular. So if it is separated in different products, this is related to product table. This is related to sales table. So we can easily segregate it and understand it. What type of data it is storing that. So it is easily understandable. Now we have two different tables. One is a dimension table and one is a fact table. One is a One is a dimension table and one is a fact table. So these are two different tables. Now, so what is the relationship between how we can see the data which is related to which one? How could we find out? So for that reason, we have a primary key and foreign key concept arrived. So that relationship, that process is called relationship. A relationship is nothing but the connection between two tables that tells how the data in them is related. So actually, you just see how this table is related to this by based on the product ID. So if you see 10104 it has a customer ID number 2, and on the 20th 2020 on Jan 1st, the sales amount happened this much. So like this we can understand. So these relationships are also in different ways. Let me explain. So how many types of relationship we have? We have four types of relationships, and one is one-to-one relationship, and second one is one-to-many relationship, many-to-one relationship, and many-to-many relationships are there. Let's see one by one. Okay, one-to-one relationship. In this relationship, we have two tables which are related to each other on single way. Okay, one to one, it have 101 to 103, 104 to 104, 105 to 105. So we have same type of data in each table, so that um, there is no increasing of columns. There is no all these are happening in one to one only, so that it is considered as a one to one relationship. And coming to next one, a one to many relationship. Here we have, so one cell Let's consider this 104. For this record we have different places were related to in the other table. Okay, we have for each record we have a different records in that other tables. That means it is considered as for one record we have multiple multiple records on the another table, so that is called one to many relationship. For one record we have multiple records on the other table relationship with the multiple records on the second table, that considered as a one to many relationship. Let's go to another table, let's go to another relationship, that is nothing but many to one. You could see same type of data you could see here. You see, um, so tables are same. Table one is table two. The main difference is the direction here, and so here the data we are seeing from this table to this table. So that means for multiple records are connected with the single value, a single record in the another table. That means, so that is considered as a many to one. Here it is many, just it is many to one. The it's may how we are connecting is the main thing. If we are connecting with the table 2 to table 1, that is a many to one relationship. If the records in the it contain table 1 contains a unique records, it is connected to the table 2, that is many to one, sorry, one to many. And the final topic is here many to many relationship. So for this you just see it has duplicates in it, even it has a duplicates in it. Let's consider first 10104. The it has multiple records. This table also contain multiple records, you could see, and each record will share the will be connected with different records from different tables. So that means we have a duplicates in it, and in this table also duplicates in it. So that may be, what can we say, many to many relationship. It has a duplicate records and multiple records for each category. For 0 104 104 105 105 is here, 105 is here, and 105 is here, you know. For each cell is connected with the common columns, related columns, it will be connected. So that means uh, it gives a cascade number. This, but this is not used in Power BI. If you want to use this, we have to build a bridge table in it. So by using this bridge table, we will connect with this table to this table, and this table contains unique IDs of each table. From each table, then we have a 101 101 104, like that we have only which are common from all both tables. So so based on that only we can map both tables. So um, we don't use many to many relationship in Power BI. So sometimes we may use. So next topic is schemas. So we, as of now, we see how tables are connected. We know what are the dimension tables. We know what are the fact tables. We know how they characterized. No, just now the topic is how they are connected with the fact tables. So, and that is considered as a schemas. How many what type of, okay, let's go with the definition from itself. In star schema, all dimension tables are directly connected with the fact tables. See, this is the fact table. All dimension tables are connected, directly connected with the fact table. Let's see. Yeah. See, like this, all are connected to the fact table. So you just see it's like a star. And so blindly you just when interviewer asks you, you could say all dimension tables are directly connected with the fact tables. So this is the most commonly used in Power BI. It is very simple and it gives a better performance in Power BI dashboards. And the second schema we have is snowflake schema. In snowflake schema, we have subdimension tables also. You know, so we have a product type. In product, we have a category also. Subcategory. From that, we have a category. So even this category also connected to the fact table, but there are three different tables through two different tables. So categories are directly connected to subcategory to product table to the fact table, sorry, sales table. So this is the fact table, this is the dimension table, these two are subdimension tables. So when you go to the definition, subdimension tables are indirectly connected with the fact tables through dimension tables. So this is, you can blindly say in interview, subdimension tables are indirectly connected with the fact tables through dimension tables. So in between them, we have a dimension table here. So these are as of now, what we discussed as of now. So data modeling before going to data modeling, we have to know what is dimension table and what is fact table here. And so we got a question like why we need a fact table and dimension table can't be store. So based on, we have some reasons to use fact tables and dimension tables. um, so, and the types of relationships in Power BI, that is one to one, one to many, many to one, and many to many. So, and how, what is one to one, what is one to many, many to one, and many to many relationships. And we this is a one question is very important. How do you manage many to many relationships? By creating a bridge table is the answer, but you have to know practically how to do it. And next topic we covered, that is schemas. How tables are connected. The designs we called as a schemas here. uh, what are the schemas we have? Star schema and snowflake schema. Okay, if dimensions are directly connected to the fact table, that is considered as star schema. If Subdimensions are indirectly connected to subdimensions are indirectly connected to fact tables through dimension table. It is called as a snowflake schema. It is not recommended in Power BI because it gives improper values. Yeah, that is the main reason. And let's go to in practical way this why we need all this one. Relationships are required. So for example, I just download the data set for your understanding, right? So this is a sales table, as I shown you in the picture in PowerPoint. This is product id. Product id has this is a product id is a foreign key here, and product table contains this thing and customer data. So we have a three different tables. Now we have to find out. Let's go. Here you can see the data modeling here. See, this is the fact table and this is the dimension table. So how can we say, yeah, how can we say this is a dimension table? Let's see the data view. um, it has a unique values, you know, unique primary key is here. So that and it has a string data, and we discussed a few things regarding characteristics of dimension table. So so that it is a dimension table and it is a fact table. How can you consider it is a fact table? Let's go to sales data. So it has all numeric values, and it is one of the foreign key here. It is directly connected with the um, product table in a with product id. So this relationship happened here. If it is not, just delete this. Okay, it will pop up like this. Just remove it, just ignore it. Just I'm removing, yeah, I just removed this table. So now we have to find out what are the sales for product id. Let's bring product id and product name to a table. Let's don't summarize it. Now I want to see the data for which product has which sales, you know, how many laptops sold, what is the sales amount for that. See, this is the thing happen. So every record, it's not filtering the data. Actually, when you see the for laptop, the laptop is 101, 101, yeah, 101. It is 180. How many 101 we have? Let's filter out this. We have only one product ID, only 101, that is a product ID for laptop. So we have to get this data, but what we are getting here, 997978. Why? Because we don't have a relationship with fact table and as well as a dimension table. So we have to build a relationship. So and see, we have a different type of relationships. So it automatically consider how what is which type of data relationship it automatically takes. Here one to many relationship happening. Why? We don't have a duplicate columns in it. It is considered as a dimension table, and it has a duplicate columns in it. It is considered as a fact table. So that in we have a only you know, in dimensions we have, it comes under one, and it comes under many. So let's go this. Now let's see what happened. Yeah, we have laptop 1180. This is what we seen here. So this is how relationship is very important. So, and this is the data modeling tab here, and you could see which table and which column is having the relationship with the another table. So what type of cardinality is nothing but a, relationship only. And product table, product id, is this active or inactive? We can make it as inactive also. Let me show you. This is the, so we can sometimes we have to use inactive relationship in our real-time projects. This is the one thing. So if it is inactive, the dotted will line appear. If you want to make it as an active, just double click here and make it this active. And this is the one other, this is one form, and you can also just turn off here and put it on apply changes. That will automatically show on the day, make it as inactive. And this is and cross filter direction. So this is going in this way, and we can could see the product details from cells. If we want to see from here to here, we have to click both and apply changes, and the direction automatically changes here in both ways. You will get to know when you start understanding the data modeling properly, why these are all are happening and all. This is for the day, guys. um, I hope you understand everything what I said in this thing. Thank you.